Graphing quadratic functions. Here we want to graph y equals -2 times the quantity x minus 3 squared plus 4. This is a quadratic equation. It's just in the special form y equals a times the quantity x minus h squared plus k. This form gives us the benefit of identifying the vertex rather quickly. The vertex is the point h comma k. So in this example, the vertex is going to be +3 and +4. So the vertex here is 3, 4. The way I like to think about it is that it's the opposite of the number right here next to x. So since this was a -3, it's +3. And then the k value we take as is. So +3, +4 is the vertex. We also can see that the a value is -2, which means that this parabola is going to open down. So a is equal to -2, which is less than 0. So this parabola is going to be a downward facing parabola. So with these two pieces of information, we're going to do a quick sketch of the graph of this quadratic function. So I'm going to go ahead and label the point 3, 4. So 3 tick marks over, 4 tick marks up. And then I'm simply going to sketch a downward facing parabola. Now, I don't know what the x-intercepts are, and although I could do the work to find them, I'm not going to bother doing that for this particular problem. I'm just going to focus on the fact that we were able to do a quick sketch of this parabola, identifying its vertex, and that it's a downward facing function. Now we want to graph y equals x squared minus 4x minus 9. So for this example, we don't have the form where we can quickly identify what the vertex is. And unfortunately, we can't find the x-intercepts without doing the quadratic formula because this quadratic isn't factorable. So we can either use the quadratic formula and be able to find the x-intercepts. We can find the y-intercept by just letting x equal 0. But if we want to find the vertex, then what we can do is write it in that nice form by completing the square. So that's what I'm going to go ahead and do here. I'm going to complete the square. And the process of completing the square, what we're going to do is we're going to focus on the terms x squared minus 4x. And I'm going to just move that -9 kind of further away. And to complete the square, we can do this because the leading coefficient is 1 here. And what we can do is focus on this value in front of x, the b value. So the value of b is -4. And the process of completing the square is that we take b and we divide it by 2. So -4 divided by 2 is -2. And then we square that quantity, b over 2 squared. So -2 squared is +4. So this is the number that completes the square. And what we're going to do is we're both going to add that number and subtract that number. And the reason why we're doing that is so that we don't change the quadratic. If we just add 4, then we're changing the problem. But if we add and subtract 4, then it's like we're adding 0. Now the benefit of doing this is that the first 3 terms factor to a perfect square. So what we have here is it factors to x minus 2 times x minus 2. And we can combine -4 minus 9, that's -13, so minus 13. So now this is the quantity x minus 2 squared minus 13. So we were able to write it so that we're in that form, a times x minus h squared plus k. So we can identify the vertex as +2, -13. So the opposite of the number next to x, and then this value out here, k is -13. The value of a is 1, so since a is 1, that's greater than 0, this parabola opens up. So I'm going to move this over to make space for my xy plane to do a quick sketch. So I'm going to go ahead and label the tick marks +2 and -13. That's going to be my vertex, and I know that my parabola is going to open upward. Now earlier I had mentioned that we can pretty easily find the y-intercept. So if I let x equal 0, the y-intercept is -9. So I'm also going to go ahead and plot that y-intercept as well, with a vertex of 2, -13, and a y-intercept of -9.